This is WPRK, and you're listening to The Crop Report. And I've got a special guest with us on the line, Dr. Stuart Ritchie, who is a postdoctoral fellow at the University of Edinburgh, researching cognitive aging and all general aspects of intelligence. And he's got a new book out. It's called Intelligence All That Matters, which outlines the importance of researching IQ and what impact it has on society. It's a great little book if you want an introductory overview of the latest research that has come out these past few years. I read it last week and highly recommend it on my part. So thanks for coming on the show, sir.
Thank you very much, and very kind words about my book. Thank you.
Just so our listeners are on the same page, can you start by giving a very basic definition of intelligence?
That's one of the hardest questions you could ask. What I talk about in the book is what have been called intelligence tests. And however you define intelligence, those intelligence tests are the things that have been researched and the things that seem to matter in the real world. And so there's a huge debate about exactly what we might mean by intelligence. But the way I define it in terms of the book is simply your performance on an intelligence test. And a lot of people might think, well, maybe these tests just, they're fairly meaningless. They just tell you how good you are doing the tests. But what I argue in the book is that actually they tell you an awful lot about a person, and not everything, of course, but they tell you an awful lot about a person,
right.
and correlate to some really important things about people's lives.
Now, intelligence in some form has been debated for centuries. Aristotle is just one of the examples that you list, but you say it wasn't until Europe gaining compulsory education in the mid to late 19th century that measuring intelligence actually became a serious discussion. So what kind of testing was being done in these early stages, and by who?
The very early intelligence research starts with Francis Galton, who was the cousin of Charles Darwin, who first became interested in what he termed hereditary genius. So he wondered why there were so many successful, eminent people in some families and not in others. And he was interested in thinking of ways to kind of measure that eminence. He was interested in measuring everything. He tried measuring absolutely everything you can think of, and he was interested in that. And he didn't invent the first intelligence tests. That came later, at the start of the 20th century, when in educational contexts they started being interested in trying to identify the children who were struggling, and helping them along. So you had Alfred Binet in France in the early 20th century, who developed these first things which we now would consider to be IQ tests, and he wasn't interested in rating everyone. He was interested in picking out these kids that were having trouble and giving them the education that they needed. And so from there on, intelligence tests developed to where they are now. And nowadays they're big business. There's large companies that design and test these tests, and yeah, it all starts with these early researchers, and a lot of them had somewhat unfortunate political views, and some of them didn't. But unfortunately, a lot of the reason people don't like IQ tests is they look back at these early historical guys and say, well, he had pretty repugnant views in a lot of ways, and so therefore these tests must not work. But
right, the evil history of eugenics, right?
Yeah, exactly. So Francis Galton, as I mentioned, was actually the guy who came up with the word eugenics.
Was Galton the one who, when he was ranking IQ, defining the different brackets of intelligence, he had some pretty politically incorrect terms now, didn't he? Or am I thinking someone else?
Well, there were a lot of guys at that point in time, not necessarily from what we would now consider to be like right-wing views. It was actually quite a liberal view to talk about eugenics at the time. And yeah, unfortunate terms about racial differences and really stuff now that we would consider to be extremely unpleasant, but was totally normal currency at the time, unfortunately, and led to some really terrible outcomes. All of this, though, we can back away from and say this is not, this is morally wrong, but it doesn't mean that the IQ tests that we use today don't tell us something interesting, and we can get onto that.
Right. Obviously morally wrong, but we still have to objectively research what intelligence is.
So the facts don't really have morals attached to them. We have to discover the facts about the world, and we can do good or bad things with them. It's still a fact that if you split the atom, it releases a huge amount of energy, and you can use that for creating nuclear energy, or you can use that for creating nuclear weapons, and you have to choose that. So there are loads of good things that we can do with our knowledge about how the mind works, and unfortunately, in the past, there have been lots of slightly unfortunate consequences too.
How do you distinguish a legitimate IQ test from the illegitimate ones? Because I'm on the internet all the time, and every now and then I'll see these pop-ups like find out your IQ in 15 minutes and stuff like that. And that's got to be bogus, right?
Yeah, absolutely. So a lot of these tests, I mean, they might give you some. They're better than just guessing at random what someone's IQ is, maybe depending on the test. But a real IQ test, a proper IQ test, is one that has been standardized. So that is a company or a psychologist or some kind of testing body has gone out and given thousands and thousands of people a representative sample of the country these tests, and often it's lots and lots of different tests that all tap into different aspects of people's mental abilities. They've gone out, given a huge sample these tests, and then set if what the average person gets, you would set that at the IQ of 100, and then you can go out and give other people those tests and compare them back to this big standardization sample.
Right.
And usually, to give the test properly, you got to sit down for quite some time with someone who really knows how to do the tests and really knows how to administer them, and then it has to be properly scored. So, I mean, that's a lot more effort to go through than just a 10-minute, Facebook quiz or whatever.
And that's also referred to as norming, right? Traditionally, you want to set it at 100.
That's completely arbitrary. It could be any number, but it's just for historical reasons. 100 is the mean of the IQ test, so the average, and then 15 is the standard deviation. So you have a little kind of normal distribution, if you remember high school stats. Around 100 is the average. So there's nothing particularly special about that number. It's just that's just the number that was chosen.
Can you game an IQ test, like just study certain kinds of puzzles that would typically pop up on these intelligence tests to kind of prepare yourself beforehand?
Some parts of the IQ test, you could do that. If you didn't have much else going on in your life, you could sit and practice. For instance, the matrix reasoning part of the IQ test, which is when you get a list of pictures, and you have to choose the picture that's missing in the sequence. And if you just practice that sort of test and you really think about what's going on in those tests, you can get better at just seeing what the rule is. Once you know that you always have to look for a rule in these sort of things, it becomes a little easier. So I guess you could practice that to some extent. However, there are some aspects of the IQ test that it's very, very difficult to practice. They include things like speed. So if you're having your cognitive processing speed being tested. Also things like vocabulary. You never know what words you're going to get asked, and so it's very difficult to, unless you just want to sit down and read a dictionary at all points of the day. It's very difficult to game the vocabulary test in that way. Of course, one important thing to point out is that people can, if you're practicing the test and practicing getting better at the test, some people will be able to practice the tests more effectively and get better faster than others, and that might be due to some underlying intelligence that they have.
Now, I want to read a quote from Chapter 2. You say, contrary to many people's intuitions, it turns out that to a great extent, intelligence is general. In other words, people who are good at one kind of mental test tend to be good at them all, which would bring us to the G factor. Why is the G factor important to understanding intelligence?
Well, one of the things people might think when they think about the people that they know is that there are multiple different kinds of intelligence that don't really relate to each other. So you might think that someone might be really, really good at doing kind of memory tests, but actually not so good at vocabulary. And you might think there might be some people who are really, really quick, but not so good at doing maths or kind of reading comprehension or whatever. But actually, it turns out that if you give people any cognitive test, and this is the most well-replicated result in pretty much the whole of psychology from the start of the 20th century, is that if you give people one kind of cognitive test, so say a vocabulary test, people who do better at that kind of test will also do better at any other kind of cognitive test you give them. So if it's a test of just picking your finger up off a button when a light goes on, if it's a test of how many things you can remember about a paragraph that's just been read to you, if it's a test any aspect of thinking of similarities between words. People who are good at one tend to be good at them all, and so they're all positively correlated, and this is what's been described as the positive manifold. So there aren't any tests that don't correlate well with all the other ones. We just can't find them. People have deliberately tried to make mental tests, cognitive tests that don't correlate with all the other ones, and they've failed every time because there just seems to be something very general about our mental faculty that can do. That means that if it's high in one person, it tends to be able to be generalized to all the different cognitive tasks, and that doesn't mean that you can't become really, really good at one type of cognitive task, and it doesn't mean that there aren't people who are very good at those types of tasks. It's just that on average they also tend to be good at all the other ones. And also it doesn't say anything about people who might have a specific learning disability, say something like dyslexia, where there's a specific cognitive task, in this case reading, that they can't do as well. But that doesn't mean anything about their general intelligence. That the whole idea of these specific learning disabilities is that they kind of they are focused on one ability, and where all of the other general abilities are quite high.
Yeah, an example you gave, which I like, is the fitness analogy, that people who do more push-ups tend to be able to run faster, which tends to mean more powerful lungs and so forth. It's all related to its own kind of G factor. Like, yes. No one would say, well, yeah, this guy can bench press 300 pounds, but I doubt he can do 3 sets of curls. It's like, yeah, they're kind of all connected, and your body is an example of having its own general factor of fitness.
Exactly. So you could really measure, if you collected a sample of people and measured them on all different types of fitness indicators, you could make a general factor of fitness. And in fact, we've actually done exactly that in some of our studies, and we've correlated this general factor of fitness with the general factor of intelligence. And so you can do this with all sorts of things. And it just, what it goes to show is that there's some underlying general faculty that underlies all these things. It doesn't mean, as I say, that this is unchangeable or anything like that. All it means is that in general, in the average population, people who are good at one type of mental test tend to be good at them all.
In the book, you describe 2 different subsets of intelligence, fluid and crystallized intelligence. What's the difference between the two?
Well, they really come into view when you look at aging. So what happens from birth is that intelligence tests increase. People get better and better and better at them. Obviously, as the child's brain is developing, the child will get better and better and better at mental abilities until it hits about age 25. And from about age 25, some of the cognitive faculties will start to decline. So you'll start to get slower, for instance. And this has been shown in study after study when they collect large samples of people at all different ages. People will tend to decline in things like speed, in memory, in reasoning ability. And these are all things that don't require any previous knowledge. So a speed test, I can give you a speed test right now, and you've never seen it before, and you could just do it. And that's the sort of thing that gets worse and worse as we age. However, there are other kinds of intelligence tests which don't seem to get worse as we age, or not so bad. So things like vocabulary, general knowledge, things which we described as crystallized intelligence seem to stay fairly stable with age. They increase and increase and increase, and then stay about the same, and aren't hit in the same way that the other types of things like reasoning and speed, which are fluid abilities, are by age.
Gotcha. So fluid would decline quicker as you get older, right?
Yeah, exactly.
Now, over the years you've spent in academia, is IQ denial largely eliminated, or have you encountered professors and higher-ups that still deny this latest research that has come out?
A lot of the time you find there's a lot of confusion, especially in educational schools. So in psychology, I think a lot of people kind of accept that this general factor is there, and it's difficult to argue against it. What you find, I think, is this kind of resistance to accepting the scientific research on intelligence. And by the way, it's really mainstream stuff. This is in the world's top scientific journals routinely. It's used as IQ is used as a measure in all sorts of studies. Particularly recently, people have been using it in terms of aging. So I just mentioned that fluid intelligence seems to decline with age, and that's a really, really mainstream topic that people are looking at. So this isn't some kind of fringe science here. You still get resistance And that resistance, I think, comes from misunderstandings. It comes from people thinking that if intelligence is general and it's measurable, it's unchangeable, and no one's arguing that. And they also worry about when people talk about genetics and the brain and how that relates to intelligence. They worry that these things mean that we're going to write huge sections of the population off. But I don't think anyone in psychology would be arguing that.
No, maybe 100 years ago, but...
Indeed, yeah.
So when we talk about IQ or any behavioral trait, most people describe the causes of human traits as being nature versus nurture, but you prefer to use the term genes versus environment. Why is that?
Well, simply because environment means a lot more than just nurture. So there are lots of things in the environment that can influence your intelligence that wouldn't be described as nurture. So, for instance, we know that people who grow up in areas that have malnourishment tend to have lower intelligence scores as children. So people have things like iodine deficiency, have lower intelligence scores. That's nothing to do with how their parents are bringing them up. That's not anything to do with parenting or interactions with the child or anything like that. It's just a fact of these areas where there isn't the diet doesn't contain enough iodine. There are also loads of things like interactions with your peers, which can steer people into different routes of education and so on that can help them improve their cognitive abilities, and so that's not all nurture. And so if you just say nature, nurture, I think people get into this mindset of thinking, well, it's genes or it's how your parents treat you as a child. There's so much more to it than that.
So I guess the better way to frame it, when we're looking at the environment, you want to separate out the shared versus non-shared environment, right?
Exactly, and this is what's described in behavior genetics research, and this is the distinction between the shared environment, which is what makes children in the same family more similar. So things like what parents consider to be, their good parenting style that they use, and then there's non-shared environment, which is things that make children from the same family more different, which is things like their peer group, which is things like educational experiences that one child has and not the other, and just general luck, things that happen to one child and not the other, encounters with people, encounters with things, injuries, whatever else that might make children more different. That's the non-shared environment. So in behavior genetic research, we split things up into shared environment, non-shared environment, and genetics.
Judith Harris put out a book called The Nurture Assumption, and she seems to lean more on the side of the non-shared environment as explaining more of life's outcomes compared to the shared environment. Does that coincide with your research?
That's right, and that seems to come out in most research on twins, and that's one of the main ways that we use to research intelligence. And we're not relying on twin research, on twins alone. I mean, twins are a bit different from other people in various ways, and people have worried over the years that twins might not be representative of all children. But we don't need twins anymore. We can actually use directly from the DNA. We can look at the genetic contribution to things like intelligence. But in twin research, which is still very useful, we can find out things like how much of the variance in their intelligence is due to things like genetics and due to things like parenting and the non-shared environment. And it looks like in many twin studies, in most twin studies, in fact, the effect of the non-shared environment is actually a lot higher than the effect of the shared environment. That is, the parenting effect seems to be pretty small compared to what we would all assume. And so it's really genes and the non-shared environment that are having the majority of the effect.
Now, when we're talking about the environment, I assume the proportion changes from country to country depending on how developed each nation is. Is that correct?
It does, yeah. Even within a country sometimes. So there was an interesting paper that came out just a little while ago showing that in people with lower socioeconomic status, so people who are maybe have lower income and live in less less socioeconomically developed areas. This is within the US. The heritability of their intelligence, that is, how much of the variation in their intelligence can be explained by genetics, is actually a lot lower than it is for people in higher socioeconomic brackets, higher income brackets. So that is, lower income people have less of a genetic effect on their intelligence. It's almost as if being living in poverty and living in the sort of environment that poverty brings can sort of suppress your innate genetic potential for intelligence, and that's quite worrying in many ways. Interestingly, it doesn't seem like that effect is found in other countries. So it's been looked at in the UK, where I am here. It's been looked at in the Netherlands. It's been looked at in Australia, and in some Scandinavian countries. And it looks like in those countries, the heritability of intelligence, the genetic effect on intelligence, is the same right across the income spectrum. Whereas in the US, you get this lopsidedness. And so it's been suggested that these countries which have more of a kind of welfare state system and are more equal in general, in those countries it might well be the case that intelligence, the environmental effect doesn't suppress the genetic effect on people's intelligence.
Now, you say that intelligence is polygenic, meaning many, many genes each contribute a small amount to IQ. So if single genes only have a very small effect on complex behavioral traits, what's the point of looking for these individual genes in the first place?
Well, yeah, that's been one of the big findings, is that it's extremely difficult to find genes that have a very large effect on intelligence. Now, there are some genes which can cause learning disabilities. We know quite a few of them, mutations and rarer genetic variants that can really cause very profound effects on people's cognitive abilities. But when it comes to the normal range, it looks as if rare variants, rare genetic variants have less of an effect, and most of the effect is thousands and thousands and thousands of common little variations in the genome that influence intelligence. You asked what the point of measuring them is. Well, we can now actually get a really good indicator of people's intelligence from looking at a genetic score. So you can take all these thousands of genes and build what's called a polygenic profile score for someone. Actually, there's going to be a new paper coming out just in the next few months that talks about that. So we're now starting to be able to look in a large sample of people for genes, and then that are related to intelligence or education or whatever you want to look for. Then take those genes and look at them in a totally different sample and see if the people who have more of those genes are more intelligent, more highly educated, and so on. And we're actually making some progress in that. We're getting not huge, predictions, but we're getting better than chance predictions of people's intelligence and their educational abilities from looking at their genetics now. And this is just going to get more and more and more detailed as genetic research progresses, and we start building larger samples, and we start understanding how the common genetic variations that differ between you and I and everyone, and then some of the rarer genes that some people carry, and we're gonna start understanding how they interact with one another to build this genetic basis for intelligence. And we're starting to make progress with that, and we're going to have to start talking pretty soon about what we're going to do with this information in order to use it ethically and make sure that no one's acting in an unethical manner with this kind of information.
Yeah, I think there's going to be many more significant findings with the GWAS studies and all that.
Yeah, well, I mean, just wait. There is literally, I don't want to say too much about this, but there is a large-scale study that's coming up very, very soon.
Is it Robert Plomin?
So Plomin is involved in that study. He's just talked about it at a conference just the other day, in fact. But just in the next few weeks, there's going to be a large-scale study that I suspect is going to cause a lot of debate about this topic.
Yeah, that's going to be exciting. One final question. So I think we've established that higher IQ correlates with higher educational attainment, but what are some other correlations that you think people would be surprised by? Yeah,
so I think one of the big things that I think people are surprised at first, and then it kind of starts to make sense to them, is that intelligence is a really good predictor of your longevity. That is, smarter people live longer. This has been found in dozens and dozens of studies, including really large-scale ones with millions of people. So in Scandinavia, everyone does their national service, and they do an IQ test as part of the national service. And so then they've been tracked by researchers in Scandinavia who have put together these kind of million people samples, which is really, really amazing work that they do over there. They have amazing records and amazing systems to deal with them. And it's really very clearly shown that people who score more highly on an intelligence test end up living longer, and it could be due to lots of reasons. So we've already talked about how intelligence is kind of this general thing that helps you in lots of different ways, and one of them might be education. So you're smarter, you end up you stay in school for longer, you end up with a better job, you end up living somewhere better, and that helps you live longer. You can spend your money on better healthcare, or whatever it happens to be. It also might be the case that intelligent people have it's a kind of an indicator of their general health. So as I said earlier on, people who are nutritionally deprived as children tend to have a lower intelligence, and they also have lots of other health effects, right? Malnourished kids don't do so well. So having a lower intelligence might actually be an indicator that there's been some problem in the past in your development. So that might be another reason that there's this correlation between living longer and having higher intelligence. Might be that more intelligent people tend to look after themselves better. Mm-hmm. They're less likely to smoke, for instance. They're less likely to drink, binge drink. They're less likely to get involved in accidents and violent situations. So that might help them live a bit longer. And it also might be that people who are more intelligent, the genes that are related to giving you a better, more efficient brain might also be genes that will give you a better and more efficient heart and better and more efficient lungs and all the other parts of the body that are really important for keeping people living longer. So that's this idea of system integrity that you often hear about, that people who have a generally better system will live longer, but they'll also have a higher IQ into the bargain. So those are all reasons that intelligent people might live longer, and there's some evidence for them all. They're not mutually exclusive, but it really does seem to be one of the best replicated findings in psychology recently, is that smarter people live for longer.
Right. Well, we just scratched the surface there, but that's some of the information that you can get through the book Intelligence, All That Matters. Dr. Ritchie, thanks so much for taking the time to come on the show.
My pleasure. Thanks.